We're going to use our S1, S2, and S3 series again, the ones we used last time. So let's initiate those. And then we also want to create this S4 series that we used. And recall that that's just a combination of series 1 and series 3. That's how we get series 4. Now last time we left off down here where we had been talking about joining by inner and outer. Remember, that's sort of an alternate to the how parameter that we used with merge. We use join instead of how. Down here, let's concatenate series 1 and series 4 again. Actually, let's do this first without the axis just to remind ourselves the difference. This is just going to stack them vertically on the 0 axis, and it creates another series. But when we add this axis equals 1 in here, we're asking it to stack it horizontally on the 1 axis instead of the 0 axis. And of course, that must mean it's going to create a data frame rather than a series. And that's an important distinction to remember when using concatenation with series. Now that we've changed S5 into a data frame, we can re-index it normally, just like we would with any data frame or series. And this is still just a normal data frame. Let's concatenate and at the same time create a hierarchical index here. And we're using series 1 twice and then series 3. So we'll get the same output, but we're going to save it in this results variable. And there it is, a hierarchical data frame. Now if we unstack this without any parameters, you might remember that it's going to take the inner index and use those for our column names. So dog, fish, cat, and goat have become column names now. But we went through 2 steps to do this. We concatenated first, and then we unstacked second. And we can approach this problem similarly by concatenating along the 1 axis and defining a hierarchical key at the same time. But notice what happens when we do this. Because we've asked it to change the axis first, the indexing behavior is different. Now in this manipulation, we did not create a new variable and we did not set in place equal to true, so our original series 1 and series 3 are still the same. So let's see what happens if we do this and then transpose. We've achieved the same thing that we did with this unstack, but we've done it with the axes argument and a transpose method. And of course we can still use the capital T here instead of transpose, and we get the same result. You might recall that from our earlier discussions in another course. And we've also started with series and converted back and forth between series and data frames. Let's create a couple of data frames. We'll do concatenate data frame 1, and then we'll also initiate concdf2. And if we output this, it's just a simple 2x2 data frame with the indexes defined. And we'll take a look at data frame 1, and it's a 2x3. Of course, data frame 1 has an additional index, bat, that does not exist in index 2. Let's concatenate these without any extra parameters initially. Of course, it stacks these vertically as expected. But if we add the axis equals 1 argument, we get a long data frame rather than a wide data frame. One more time, let's back out of this, run this again, and compare the vertically stacked with the horizontally concatenated version. Run this one more time. We get a lot less empties here, and we should be able to interpret what has happened here by now. Now we can also add a hierarchy here using this keys argument. So let's put this in here and run this one more time. And where do you think those hierarchical keys are going to appear since we're using axis 1? They appear hierarchically in the columns because we're using axis 1. So let's remove axis 1, run this one more time. The hierarchical keys will predictably occur in the rows rather than in the columns. Now we can be more specific as far as where we want these hierarchical indices to occur just by using a Python dictionary to define them in this manner. So let's run this, and we get a similar output. And again, predictably, if we include this axis 1 parameter here, those hierarchical indexes are going to move to the columns, and we're going to get a short rather than a long data frame as a result.